In outer space, breathing becomes a crucial factor. Imagine, before leaving the safety of your ship, you are required to exhale completely. Otherwise, the air left in your lungs will start to expand, which can have catastrophic consequences for your body. But once you exhale properly, you have about 15 seconds of consciousness before the lack of oxygen causes you to lose consciousness. The vacuum of space is not just the absence of air. There is no medium here to transfer heat, so the human body will lose heat only through radiation. It's interesting to note that sweat and saliva start to foam, but this isn't due to boiling in the usual sense. This happens because of the reduced pressure, which causes evaporation at normal body temperature. It's also important that, contrary to myths, the body does not explode in space. The skin and tissues hold in the internal pressure, maintaining integrity. However, without timely medical assistance within a minute and a half to 2 minutes, the consequences can become fatal. Now that the main secrets of the vacuum have been revealed to you, the question arises, what other factors determine the interaction between humans and space? The answer lies in how our physical characteristics can adapt and survive in such extreme conditions. Outer space vacuum is an extraordinary place where the familiar conditions of our existence change dramatically. While on Earth we are surrounded by an atmosphere, in space the pressure approaches zero and molecules are almost non-existent. For example, in remote regions of space there are only about 1 particle per cubic centimeter. This makes breathing without special equipment impossible. What is especially surprising is the way heat is transferred in a vacuum. Since there is no air or any other matter in space to conduct or convect heat, energy is transmitted mainly through radiation. This means that heat exchange depends on infrared and other spectra of radiation from stars and celestial objects. It is also important to understand that the cosmic vacuum, although incredibly empty, is not absolutely void. There are always individual particles and radiation present here. Therefore, even in such an environment, the fundamental laws of physics continue to operate. But we observe their manifestations differently. The vacuum does not cause irreversible changes to matter as such. However, significant loss of matter due to evaporation and the escape of molecules from the surfaces of objects is quite possible here. The mysterious nature of the vacuum reveals to us the astonishing aspects of the cosmos. And this is only the beginning of our exciting scientific expedition. It's time to explore how the human body reacts to such an unusual environment and whether our physiology can truly withstand such challenges. When the human body finds itself in the conditions of open space, it faces a number of incredible challenges. There is no oxygen around, and after 10 or 15 seconds, hypoxia sets in, when the brain stops receiving the necessary amount of oxygen, which leads to loss of consciousness. However, contrary to fears of instant death, our tissues and skin are strong enough to temporarily protect our internal organs from immediate destruction. The low pressure of the vacuum causes a unique phenomenon, evaporation, when the fluids in the body begin to vaporize. And although this sounds frightening, the body does not explode or swell up dramatically. However, other problems, such as exposure to radiation, still take their toll. Radiation and the thermal emission from stars are indeed dangerous, but their long-term effects take time and do not strike instantly. Despite the apparent silence and lack of air, space fills us with wonder. It is a soundless grandeur and invisible energy stretching beyond the horizons. External temperatures do not cause instant freezing or overheating, since heat transfer in a vacuum occurs slowly. The mysterious nature of the vacuum raises the question of how much these myths intertwine with reality. But there is one more important detail related to exhaling. Those venturing into open space must remember to exhale beforehand, otherwise the expanding air in the lungs can cause serious injury. However, beneath this lies something far more intriguing, connected to popular misconceptions about exhaling in space. Exhaling in outer space is one of those topics that generates so many myths and misconceptions that it's hard to separate fact from fiction. Let's start with the fact that a person does not instantly freeze or explode. The elasticity of tissues and skin prevents destruction during sudden decompression. A vacuum creates conditions in which temperature does not transfer to the body instantly, so freezing does not happen immediately. However, the gradual cooling of all body tissues remains inevitable. It's also important to understand that holding your breath when going into space is dangerous. If you don't exhale, the expanding air in your lungs can cause barotrauma. This is exactly the moment that is critically important for survival. You need to exhale before leaving the safe space of the spacecraft. Another myth is related to the idea that the fluids in our bodies boil instantly. In reality, the process is more like accelerated evaporation than instant boiling. All of this is supported by real scientific data. Loss of consciousness occurs after about 15 seconds due to oxygen deprivation, and death follows in about a minute and a half. Although this time may vary slightly, many myths about space persist in our culture because of their dramatic portrayal in movies. But reality is often much more complex and sometimes even more interesting than fiction. The epic of space and its mysteries continues to captivate our imagination. That's why studying the scientific facts about human interaction with the vacuum is so fascinating. There is still so much amazing yet to be discovered that space can reveal to us. And it's not limited to just questions of breathing. In open space, breathing becomes a dangerous task. Without air around, there is a risk of barotrauma if you try to hold your breath during sudden decompression. Imagine that the expanding air in your lungs can seriously damage your airways. That's why astronauts are strictly instructed to fully exhale before leaving the spacecraft. The body in a vacuum faces not only respiratory system problems. In low-pressure conditions, the body's fluids begin to spontaneously vaporize. This phenomenon, known as ebulism, leads to the rapid formation of gas bubbles in tissues, causing dangerous poisoning. In addition, there is no medium for heat transfer in a vacuum, so the body loses heat only through radiation. Although instant freezing does not occur, gradual cooling remains inevitable. Contrary to possible misconceptions, our physiology cannot adapt to a vacuum. Without a protective spacesuit, even brief exposure to vacuum is deadly. Astronaut training is aimed only at minimizing risks in emergency situations without the possibility of full adaptation. Our internal processes, such as the functioning of the lungs, depend on the specific pressure and abundance of air found only on Earth. All of this highlights that survival in space is a complex challenge, requiring not only scientific understanding but also strict protective measures. When faced with the vacuum, we discover a fascinating and sometimes frightening interaction between our planet and the boundless expanses of outer space. And yet, interacting with this alien environment raises many questions that require deep scientific analysis and further research. Imagine, in open space, there is a total absence of pressure. If we exhale before depressurization, the risk of barotrauma to the lungs decreases. The fact is that the unusual expansion of air rushing out of the lungs happens slowly if there is no attempt to hold one's breath. This is confirmed by real cases where barotrauma in vacuum conditions generally turned out to be mild. But this does not eliminate another danger, the loss of consciousness due to hypoxia. After 10 or 15 seconds, the brain begins to suffer from a lack of oxygen. After that, without oxygen support, death can occur within 1 or 2 minutes. The main causes are not barotrauma, but general oxygen deprivation and the resulting internal damage. Nevertheless, it is impossible to freeze instantly in space. Although the body loses heat, this process occurs through radiation, not convection as it does on Earth. Such heat transfer happens slowly, so there will be no instant freezing. Solar radiation, in turn, poses a significant danger in space. Radiation can damage tissues, but not instantly. Short-term exposure can cause burns, but there is no sudden tissue destruction. And of course, an important factor is decompression sickness. When pressure drops suddenly, gas bubbles begin to form in the blood and tissues, creating a risk of serious injury. But don't be quick to fear an instant explosion or your blood boiling. These are myths that NASA scientists have long since debunked. Each of these factors paints a picture of the complex interaction between humans and the space environment, opening doors to new discoveries and research. In this boundless vacuum, there is always something else waiting to be discovered by scientists. As soon as the air molecules leave our lungs, an astonishing process begins in the conditions of space vacuum. Without the pressure we're so used to on Earth, the gas in the lungs rapidly expands. This process is called explosive decompression. The vacuum into which the molecules enter does not hold them back, and they instantly begin to spread into the surrounding space. In such conditions, breathing becomes impossible, because air is no longer a life-sustaining mixture, but simply chaotically moving molecules leaving the body. A person loses consciousness within 10 to 15 seconds due to the lack of oxygen, making survival in space without special protection an unattainable goal. Here's another interesting fact. The fluids in our bodies begin to boil at body temperature due to the sudden drop in pressure. This doesn't lead to instant death, but through the very process of boiling, the body loses precious heat, gradually cooling down. Historically significant experiments help us understand these processes better. One such case is the famous jump by Joseph Kittinger from an altitude of over 102,000 feet in the rarefied conditions of the stratosphere. This demonstrated how low pressure affects the human body. Space stations, where astronauts spend many months, are equipped with complex air regeneration and purification systems. These devices make it possible to maintain a normal atmosphere inside the modules even in the vacuum of space, protecting against the all-pervasive cosmic environment. And interacting with this boundless environment always raises new questions and challenges, the study of which may open the way to further scientific discoveries and technological achievements in space exploration. And yet, space still holds many secrets that scientists have yet to uncover. Let's begin deciphering the mysterious experiments that NASA is conducting to understand the effects of vacuum on the human body. In the 1960s, NASA began studying the effects of rarefied spatial environments by subjecting test subjects to limited exposure to low pressure in special vacuum chambers. Although no one has ever deliberately exhaled under such conditions, information about short-term survival without protective equipment emerged as a result of aerospace research data. Numerous studies are being conducted on the International Space Station regarding living in microgravity conditions. And although these studies are not directly related to decompression or exhaling in a vacuum, they are aimed at gaining a deep understanding of the physiological adaptations and responses of the human body. Changes are observed in the cardiovascular system, bones and muscles, as well as in the specifics of gas exchange in the absence of gravity. The issue of decompression and its potential consequences requires special attention. Astronauts undergo adaptation to respond quickly to sudden pressure loss, using training and equipment for protection. Despite the rarity of such cases, developing safety strategies in space conditions helps minimize risks and enables effective response in emergency situations. Any decompression outside of a protected area in a vacuum remains a deadly prospect. Even short-term exposures can leave long-term consequences, and immediate assistance is required to restore normal condition. The conclusion is this: preparation and understanding of all space threats are the key to safely conquering deep space and to better understanding our interaction with the vast boundaries of the universe. When the human body is exposed to the harsh conditions of open space, an extraordinary interaction with the vacuum occurs. In the event of sudden decompression, the gas in the lungs rapidly expands, causing hypoxia, a lack of oxygen, which leads to loss of consciousness in less than 10 seconds. However, contrary to popular myth, the body does not explode. Bodily fluids begin to boil due to the sharp drop in pressure, but the structural strength of tissues limits the extent of this process. Freezing also does not occur instantly. Heat is lost slowly, since in a vacuum heat transfer occurs exclusively through radiation. Ebulism is a phenomenon where gas bubbles, mainly nitrogen, form in the blood due to low pressure. This condition can cause paralysis and long-term damage, making exposure to vacuum extremely dangerous without proper protection. Radiation in space poses a serious threat, penetrating tissues and causing cumulative damage to cells and DNA. This happens slowly, but the effects can be devastating in the long term. Changes in internal pressure can also affect the senses and the brain, causing vision and hearing disturbances. These phenomena have been tested and studied in numerous experiments. For example, in 1966, in a NASA test chamber, one of the participants managed to survive a brief exposure to vacuum, which became a valuable source of knowledge about the human body. Thus, the lack of protection in space poses serious consequences for the human body. These facts highlight not only the harshness of the space environment, but also the necessity of ongoing research to ensure safety as we explore the frontiers of space. New achievements in this field will open the door to a deeper understanding of how humans interact with the boundless expanse of the universe, prompting us to consider just how far our cosmic ambitions can go. Issues of protection and adaptation to these conditions require close attention, especially when lives and health are at stake. When astronauts go into space, ensuring their safety becomes a matter of vital importance. And here, every element plays a crucial role. Spacesuits, which provide protection from vacuum and radiation, play a key role. However, contrary to popular belief, they are used only at critical moments, during launch, spacewalks, and emergency situations. Aboard the ISS, astronauts work comfortably in regular clothing, putting on spacesuits only when necessary. Space radiation is another factor that poses a danger. Special materials and shielding are used to minimize exposure, but it is impossible to completely eliminate the effects of radiation. That is why the time spent in orbit is strictly limited and careful measurements of radiation doses are conducted. Possible health consequences include risks to the central nervous system and the immune system. Astronauts are trained to act under any conditions. Emergency scenarios and risk management are thoroughly practiced. The ISS has documentation with clear instructions for emergency situations, and the crew commander coordinates safety and monitors the fulfillment of duties. Nutrition and physical activity are important elements of life in space. Weightlessness affects muscle mass and bone tissue, so exercise and diet are strictly regulated. And for moral comfort, communication with Earth through video calls is also important. Modern research is aimed at improving technologies, developing spacesuits, and life support systems. The implementation of artificial intelligence for health monitoring is not a distant future, but already a reality in test mode. These innovations will be crucial in upcoming interplanetary missions. Recent incidents show that although there is still risk in flights, the level of safety has become significantly higher. Cases involving micrometeoroids and malfunctions in systems are just some of the challenges that astronauts successfully overcome thanks to training and technology. These facts highlight that, despite all the difficulties, research and development are making space travel increasingly safe. This opens up new horizons and opportunities in our quest to conquer the boundless expanses of the universe. Space medicine is a fascinating field that helps astronauts cope with the challenges that arise in weightless conditions. In the first days in orbit, fluids in the body redistribute, leading to facial swelling and a feeling of heaviness in the head. These processes are not limited to this. The cardiovascular system functions differently, increasing the strain on the heart. To maintain their physical fitness and health, astronauts use specially designed equipment for strength training. These exercises are adapted to the unique conditions of microgravity and are strictly individualized. This makes it possible to minimize the loss of muscle mass and bone density, and to maintain the body's performance. On board the ISS, portable laboratory complexes are used, allowing blood analyses and biomarker testing to be conducted on site without the need to return samples to Earth. This speeds up diagnostics and allows doctors to make decisions more quickly to maintain the crew's health. Telemedicine plays a crucial role in remote consultations, although data transmission delays pose a challenge, especially for long-distance missions. That is why autonomous systems are being developed that will be able to diagnose and treat astronauts directly on board. Research on the ISS covers the cellular level, including testing new medical drugs. These studies are vital for preparing for long-duration flights, such as missions to Mars. Space medicine is becoming an integral part of humanity's preparation to go beyond our planet. This field is closely connected with engineering and biology, providing a comprehensive approach to protecting astronauts' health. Space challenges us to look into the future, where medicine and technology will unite to help humans conquer new frontiers. But will this integration be strong enough to overcome all the barriers on the way to the stars? A question that demands answers and further research. Space is a realm of mysteries and at the same time serious challenges. Exhaling in a vacuum is a harrowing experience, not so much because of the act itself, but due to the sudden drop in pressure. If air is held in the lungs, the gases expand instantly, posing a threat of severe injuries. This demonstrates just how crucial safety protocols are for astronauts. A vacuum is not enough to sustain life. The lack of oxygen and pressure means a constant threat of decompression and hypoxia. Here, airtight suits with life support systems play a crucial role, providing astronauts with oxygen and protecting them from dangerous radiation that damages DNA and increases the risk of cancer. Besides the vacuum, space is characterized by a state of weightlessness, not because of the absence of gravity, but as a result of orbital free fall. This condition has a specific impact on the body: reduced bone mass, loss of muscle strength, and fluid redistribution, which leads to unusual facial swelling. An interesting point is the study of the dark genome, which affects stem cells and accelerates aging. These topics require attention, as scientists are now closely studying their clinical characteristics. Despite these unique challenges, science tirelessly explores the aspects of survival and life in space. And there is still plenty of room for further research. The possibility of adapting to space is a hypothesis based on bold scientific assumptions. We are only just beginning this journey of exploration, and each step brings new knowledge and amazing prospects for our future in interstellar expanses. Indeed, space still holds many secrets that remain to be uncovered.